Hello. My name is José Eduardo Gutiérrez Montoya, from the Centro de Estudios e Investigaciones Interdisciplinarios and the Escuela de Sistemas Unidad Laguna, both part of the Universidad Autónoma de Coahuila aka UADEC. Thank you for joining me.
In this poster, Towards Reliable and Low-Cost AI Assistance for Welding SMEs, a Retrieval-Augmented Generation Approach, I will present a low-cost AI assistant that gives trustworthy, source-grounded welding guidance, and the experiment we ran to test it. This is joint work with my co-authors from UADC and UPAP. Let me start with the problem. Welding is a knowledge-intensive and safety-critical process. It requires command of metallurgy, process parameters, and strict safety and quality standards. But in small and medium-sized enterprises, SMEs, that expertise is often hard to access. Skilled personnel are scarce, formal training is costly, and specialized digital tools are rarely adopted. General-purpose large language models look like an easy fix because you can ask them technical questions in plain language. The problem is that a general model answers fluently, but it usually does not tell you where its answer comes from. And it can hallucinate, that is, produce confident statements that are simply not supported. In a field governed by normative documents, an answer you cannot verify has limited value and can even be dangerous. So our objective was to build a low-cost, serverless RAG assistant, that is, retrieval-augmented generation, that grounds every welding answer in authoritative standards and cites the exact source, down to the page. And then to test, rigorously, whether this domain-specific retrieval actually improves reliability compared with the same language model without retrieval. Our hypothesis was that the RAG assistant would outperform the baseline across 5 quality metrics, with the largest gains in grounding and in hallucination control, the dimensions where having the source in hand should matter most. Here is the approach. The whole system runs on low-cost, serverless infrastructure, so it fits the budget of an SME. Users talk to it through a messaging app, Telegram. The logic runs on Cloudflare workers, documents, passages, and their embeddings are stored in a managed database, Cloudflare D1, and heavy document processing runs asynchronously through a queue. There are 2 flows. In the ingestion flow, a standard is uploaded as a PDF. Its text is extracted page by page, split into overlapping passages of about 1,200 characters, each tagged with its page number, and stored as vector embeddings. In the query flow, the user's question is embedded and matched against those passages by similarity. The most relevant passages become the context, and Gemini 2.5 Flash generates an answer that is grounded in that context and cites the document and the page. That page-level citation is the key idea. It is what turns a fluent answer into a verifiable one. For the knowledge base, we used authoritative sources only. The ANSI/AWS Z49.1 safety standard, and the shielded metal arc welding chapters of the AWS Welding Handbook, about 159 pages and 499 page-anchored passages. We deliberately excluded vendor-specific manuals to avoid source bias, and we scoped this study to one process, shielded metal arc welding, or SMAW. Now the experiment. This is a design science research study, and our baseline is important. It is the exact same model, Gemini 2.5 Flash, but with retrieval switched off, answering from its own parametric knowledge, with no document context. By keeping the generator identical, any difference we measure comes from the retrieval component and nothing else. We built 12 representative SMAW tasks in 3 categories: parameter selection, procedural or document questions, and troubleshooting. Each task went to both systems, giving 24 answers. For every task, a domain expert defined a validated reference answer and its source passages to serve as ground truth. The evaluation was blind and counterbalanced. The identity of each system was hidden and randomized for every task. Because domain experts were not yet available, the scoring was done by a panel of 3 independent frontier language models from 3 different providers, acting as judges: GPT 5.6 Sol from OpenAI, Gemini 3.1 Pro from Google, and Claude Opus 5 from Anthropic. Each judge scored every answer from 1 to 5 on 5 metrics: accuracy, relevance, trustworthiness, grounding, and hallucination control. Here are the results, and they are clear. The RAG assistant beat the baseline on all 5 metrics, and, exactly as we hypothesized, the significant gains are concentrated where retrieval matters most. Trustworthiness showed the biggest jump, from about 1.6 for the baseline to 3.7 for the RAG assistant, a highly significant difference with a very large effect size. Grounding rose from 2.5 to 4.2, and hallucination control from 3.3 to 4.2, both statistically significant. Accuracy also favored the RAG assistant, from 3.6 to 4.4, although that difference was only marginal, which is expected with a small sample of 12 tasks. And relevance was essentially tied, around 4.3 for both systems. That makes sense. Both systems answer the question, but only the RAG system grounds and attributes what it says. 2 more points. First, the agreement among the 3 independent judges was high, an intra-class correlation of 0.89 and a weighted kappa of 0.72, so these scores are reliable. Second, the RAG advantage was largest for the documentary and procedural tasks, where the answer depends on specific normative content. To conclude, domain-specific retrieval made welding guidance measurably more trustworthy and better grounded, and it reduced hallucinations. And because both systems shared the same generator, those improvements are attributable to retrieval itself. Just as important, the whole system runs at very low cost, which makes grounded, source-attributed welding guidance realistic for resource-constrained SMEs. I want to be transparent that this is a preliminary, automatic evaluation using language model judges. The confirmatory evaluation with human domain experts and a broader corpus beyond SMAW are our next steps, and they are already underway. Thank you very much for your attention. I would be glad to discuss the architecture, the evaluation, or the results. Please feel free to reach out to the corresponding author. Thank you.